Well, y'all want to jump into the quiz?
It should be. I don't think it's gonna be too hard.
Yeah.
Like, it's pretty. From what I got, it seems to be the exact same thing. Well, not the exact same thing, but it's. I find a p hat was the same as finding a z-score or.
No, find the mean, the sample mean.
Yeah. The mean. It was just p hat minus p divided by the square root of this. The only difference was it was just the square root of this, not. Anyway, it was. Other than that, some pie charts and stuff.
Yeah, I like the Pareto chart. I thought it was kind of funny. It's probably a guy named with the last name Pareto, and that was just he was like, wait, let's take a bar chart and make it go in descending order, and that's like his claim to fame. I mean, because in order to make it, you just have a bar chart, and then you make it go in descending order.
Yeah. I bet lots of people were doing it already. He was just the one who named it.
Yeah. Good old Pareto.
All right. Well, I got my quiz open now.
You want to start with question 3?
Yeah. In question 3, in a pie chart, why are the slices or sectors different sizes? Isn't that just because they have different amounts? And okay, well, let's see. That's not the size. It's definitely not random. Each slice represents a category, and yeah, I think it's C. Each slice is a category, and the area of each slice represents a proportion of the total occupied by the cat. Is that right? That sounds wrong, but I'm sure that's right. Yeah,
I think it's right. It shows different proportions of the total.
I think it was worded weirdly, but it can't be anything else. It's not random. It's not visual. Well, it might be visually appealing. I don't know. Yeah, I think C is
The
better.
slices are different sizes.
I think C.
Can I do 4? That looks easy too. In fact, you already did 4 technically. How are bar charts and Pareto's related? Well, they're the same thing. Just one's Pareto's are descending, or it says largest to smallest.
Mm-hmm.
So yeah. All right. So someone could take 5 now.
I'll take 5.
Oh, I need a calculator now. Oh,
So it says we can conclude that you called it p hat.
I think that's what they actually call it, p hat.
P hat is normally distributed if n times p is greater or equal to 10. Is p the true proportion or the sample proportion? I think it's the true proportion because p hat is the sample proportion.
Yeah, it's like I'm mixing them up. I think it's like mu versus x bar.
Yeah.
Yeah.
Okay. Mu is less realistic because that's representing the population. If you murder wise, you probably wouldn't need the statistic.
Ow. Yep. All right, and Eric, do you want to take number 6?
Yeah, number 6. What's in?
We've done this. We've been doing this for weeks.
Sample size.
Yeah.
Yeah. They're usually pretty easy when it's, the first one after a test or something.
Yeah.
It's like, all right, let's number 7. If p equals 1/4, what is the smallest n that satisfies the requirement? Oh, okay. So what p times 1.25 times what equals 10? And also it has to be negative. All right, well, times.
So it's p times 1 minus p over n.
Yeah, it needs to do both,
Square root.
but I'm pretty sure the negative one will go higher. Because as of right now, to satisfy the first requirement, it needs to be at least 40. Smallest is 40, but the second one times 1 minus 2.5. Okay. 50. Okay, it's between 50 and 60. Ah.
Hmm.
All right, I got.
Which formula are you using?
Oh no, it's just the what do you call it? In order to use it as a valid or normally distributed sample size, it needs to. It's right above number 5. It needs to match those two, unless this is something different. I'm pretty sure this is just we just need one that's normally distributed.
So we just need it to equal or be greater than 10.
Yeah. Yeah. For both n times p and for n
Times 1 minus p.
1 minus p. And I've got it down to 53.35, but I need to get even smaller than that. Oh,
Okay.
so close. This is really annoying. All right.
Well, 1 would just be 40, correct? Since we'd multiply it by a quarter, that would give us 10.
Oh yeah, that's pretty easy. The first one would be at least 40, but in order to fulfill both, I think rounding up, it would have to be. No, it needs to be. No, it needs one more. 53.333. Because if you do 53.333 times 1 minus 1/4, you get, 39.9997 when you round it up, and that's becomes a 40.
So you are doing n times 1 minus.
Wait, I don't. Oh yeah, but I don't think n can be what do you call it? Points, a decimal, because you can't really have half a sample size of something. So I think it needs to be 54. Yeah, but the formula is on question 5.
So I just did 40 times 1 minus 0.25. and I got 30.
Oh yeah, it's
So
because
I think
oh yeah.
so. I think 40 would be the smallest that could satisfy both of them. Because we need 40 to satisfy the first one, and then
Oh wait, I think I totally misunderstood something. Yeah, I think it would be 40 also. Hold
yeah,
up.
because
I think
40 gets us above 10 for both of them.
yeah, I totally messed that up because 40 1 minus 2.5. Yeah, that was honestly my mistake. For some reason, when I got 30, I was thinking I needed to get
40.
for some reason 40. I thought I had to get back up to 40 again. So yeah, it's 40.
Yeah.
Thanks.
Well, I'm glad you knew how to.
I got lost, but that's it right there. That's your formula.
Okay. Yeah. See, I didn't really know how to use it before, but that makes
Yeah.
sense.
It's
I think.
it's like the normally distributed the other type of test needed a sample size of 30. This one's just has a different rule.
Yeah. Or like the weird one with F
Mm-hmm.
like it can't be the larger can't be 4 times the size and smaller,
Mm-hmm.
something like that.
Yeah. It's just another rule to remember.
Is it everybody ready for 8?
Yeah.
Okay. So it says suppose n equals 24 and p equals 0.4. What is the mean of p hat?
So what is p hat?
So mean of p hat equals p.
Two would be
So
the
I think
same.
it's just 1.4
Yeah.
since they give us p. What is the standard deviation of p hat? That would be 0.4 times 1 minus 4 over 24.
I don't remember. I thought it was supposed to be like. Oh, hold up. All right.
I got 0.1
Okay.
when I use the equation.
That's what I got too.
Hold up. I'm almost there. Oh, no, no, no. Oh, that was close. All right. You got 1.1? What was it?
I got 1.1.
0.1. Okay, I did all those multiplications. What did I find the square root of?
It's the square root of p times 1 minus p over n.
One minus. Oops. Gotta do it again. That's weird. Oopsie. Oh, maybe it did the wrong way. Oh, hold on. I think I got it. Ah. All right. Point.
All right, number 10.
Was that me?
Okay, so I read number 10, right? So Britney's batting average is 0.300. We want to determine the probability she will get more than 35 hits in her next 100 at bats. N equals 100 and P equals 0.3. What is P hat? What's P hat?
Huh. So the mean of p hat equals p, but how do we find p hat? Which is p.
So here P is the proportion, right?
P is
The true. P is the true proportion.
Yeah.
So that means that we already know that she hits 30 out of 100. That's her number. But if we were to do a separate sample, what's the probability that she would get 35 out of the next 100? And so how would we find just p hat?
hold on. P hat. So P is the sampling distribution. P hat. I don't remember. I feel like SRS of size.
Okay,
Okay. Hey,
so
P hat.
yeah,
I
go
just
ahead.
found the equation.
I did too.
Yeah.
So it's x over n.
Mhm. So that would just be the 0.35 over 100. Which would just be 0.35.
So that would be x. So what's the answer you got, Trent?
I think it's just dividing 100 by 30, or no, 30 by 100, which would 35 divided by 100, which would give us 0.35.
Yeah, because X is supposed to be like something of the population of certain significance, as in like, well, how many out of the 100 did she hit? Like of 100 balls, you're looking of the hit of the significance of was hits, and so yeah, so yeah, 30. So 35 divided by what was it? 100? The 0.35, or to be 35 divided by 100.
Yeah, because 35 is X. That's the population
I did
sample that we want.
0.35 for some reason. That was way low.
Yeah.
All right. All right. And after that, standard deviation should be pretty easy after the last one we did.
P hat equals X over N.
So
Can't believe I didn't write that one down. No, I actually had issues with the standard deviation I got, but I had a hard time figuring out the z-score of P hat.
this
But the standard deviation.
oh,
It's the same one that we used earlier. It's P times 1 minus P over N. So that's the square root of all that.
All right. All right.
Huh.
Thought this would be easy. Maybe I did it wrong because I'm getting like a very, very small number. Oh, wait, I did it the wrong way. Never mind. Hold on. Okay. Okay, so what I got for 11 is 0.0458. So rounding that up, that's 0.0 or 6.
Or in the equation, did you use p hat or p?
P.
So that would just be 0.3, but that's not really the standard deviation we want, right? Because we already know. I don't know. I don't see why we're solving for p if what we really want is p hat. But the equation calls for p. Oh, okay. Because we need the standard deviation of the true, since they gave us the true proportion. We need to know that in order to. Okay, never mind. I'm just resisting.
So I got 0.046 rounded to 3 decimals.
Oh, let me. Up. Yeah, I got 0.046. What did y'all get?
Yeah, 0.046. For 12, you said you remembered the formula for the z-score, right? It was the same as
Or I thought I did, but when I was doing the example problems, I couldn't get it.
Oh.
Couldn't get it right, so I'm gonna look at the formula again. Make sure I got it. I have it written down correctly.
So I have the formula here. I'll share it with you real quick.
It looks fairly simple.
You guys see it?
Oh, hold up.
It's right here in the right side. So we have to use p hat minus p.
Yeah, that's what I was remembering. It was like, that's what I was saying earlier. It was the, so it was 0.35 minus 0.3.
Yeah.
Let me put that in parentheses. All over the whole thing with the square root
of the standard deviation, which would just be 0.046.
Yeah, you're right. That was good. That was good. I didn't see that was a standard deviation at first.
Yeah, we already did it.
Should we put in our rounded score, or should we do like what we did before, the 5/8? Because since we shouldn't round until it's all done. So I'll do the. Someone do it with the 0.46, and I'll do it with the 5.5. Oh, you know, the old one.
45826.
Yeah, I'm okay. And then someone else do it with our rounded number, and if it's okay, because as of right now, with the using the unrounded number, it is 1.091.
With the rounded number, it gives you this 1.087.
You know, there's an easy way to solve this.
How's that?
Just I'm going to enter it in like the whole square root. You know the p hat minus p divided by the square root of, and it's going to enter that whole thing in, and we'll whatever comes out should be what's correct. 0.3 minus 0.3 divided by. Did I do that right? So divided by the square root, so that's 0.3 times 1 minus 0.3 divided by 100. Okay, because when I do that, I get, oh, okay, 1.091. So, yeah.
Yeah,
It
I
would be,
think that's actually the correct way to do it. So I was planning to put in 1.091.
yeah, I just want to double check to see. We'll just have to remember in the future that whenever we do that, keep a note after we round it, keep a note of what it used to be before it was rounded. The true number, I guess. Alrighty then.
So it looks like we now take that and put it into the probability applet.
Oh,
Yeah.
I was wondering if you actually would use that.
Oh no.
Excuse me.
And it's just a one-sided test, correct?
Yeah. We're looking for less than, right?
Well,
Mm,
I never thought about this. I assume it would be less than, but what would the mean be?
So what's the probability to get less than 35? Okay. So you have to shade the. First, we have to enter that z-score in the right side, and then less than that. So I get 0.40, 0.60, 0.86
Oh, I don't know what happened. My z-score suddenly was wrong. There we go.
0.622.
Hello. All right. So would we do the middle and the left, or just the left?
I think it would just be one side.
What prescription is it?
I don't remember this one. It also seems kind of weird to use a probability applet.
Yeah. So
But
so
I think we would use this as a.
I think that one is the old.
I don't know. I would wait. I would be more for just the left side.
Okay, thank you.
I think it's the left side and the middle side too.
Hmm.
What is the probability Brittany gets at least 35 hits? Next. Well, her batting average right now is 30 hits in every 100 bats. So I think that her getting 35 would actually be pretty slim. Because that would be an unusually high number of hits for her normal average.
Oh, that's right. We can. That. Oh.
Well, there's 3 of us. We could try 3 different ways and see which one comes out right.
I will trying to see if I can find an answer real quick in the reading. All right. No, not. Here we go.
The coin toss example, I think, might answer it.
Oh, excuse me. Ugh. All right.
So, in order to find the probability that something exceeds a certain number, we only shade the tail on the right.
Okay. So. That's hard because wouldn't is it asking if it's how much it's just saying what's the percentage of gets 35. So I would it is asking in a way what is the chance of her hitting more hits. So I guess that would be saying how if it exceeds in a way. But either way, that would be one-tailed, and it would be the same thing on the other side. But well,
I'm gonna try 1.138 and see if that I get it right that way.
I'm thinking I think it's 138, just the one. It's not. I don't know because she's almost there, so it wouldn't be that unlikely for her to hit 5 more over her average. But I don't know. It's an average for a reason.
Yeah, if we were to...
Oh, there's also another thing. This is the standard deviation is just so it's simple 0.5. So another way to think of it is let's see 0.3 plus 0.045. It's pretty much just over 1 standard deviation away, which we know is 60%. You know, what's the chances it'll be? So with that in mind, seeing it's just over 1 standard deviation, then it might, and that would mean it's there's a 66.7, 66.8% chance of being in there. So it wouldn't be so far-fetched to think that it might be the middle and that, because the middle and the right side. I don't know. Both could work.
Okay.
Okay. Tell you what. How about you do it that way, and I'll do it this way, and we'll just find out at the end, rather than spending another few minutes on this. Because we know how to do it, we're just not sure which way to do it. So, rather than, I guess the most correct thing to do would to find out the answer and study some more. or we can just do some trial and error.
Yeah.
So anyway, and
I'm
this
gonna
way's
put it in
faster.
0.138.
Okay, and I'm gonna put the middle and the right, 0.862. And if we're both wrong, then I don't know. I guess we did need to
We got a
study more. All right, let's just get this over. We got 3.
If the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P hat?
Well, let's do this again. 1 minus 5.2 divided by 2,000. Okay, I did it real quick, and unless I entered it wrong, it should be 0.011.
What is X though?
I would guess it's 50, just 0.5. No.
Getting less than 50%.
So what
Would it
do
be
you
like-
get for your answer?
Because that's the only other number we're getting.
So P equals 0.52. We want to determine the probability that the results of the survey will suggest that the candidate is losing the election. So losing the election would be 49%. Does that make sense? Y'all?
The true probability who's for the candidate is. You answered it. So the survey was just. Well, yeah, it needs to be at least 49%. So I guess we could use that. Yeah.
And
so for this one, it'd be equal or less than. How am I supposed to find the z-score of this?
so for the standard deviation of P, using 49% or 49 over. Wait a second.
I think this would just be the regular P for this first one, because we need to get a.
Yeah, is X different than P though?
X is if I remember correctly, X is supposed to be something of a certain significance. So X would be, I think, would either be, well, it depends what you're looking for. X could be the people who are going to vote for this person, or the people who won't vote for him. So how are you supposed to do a percentage? Do you just enter in the whole number? We'll do 2.5. Because everything I'm doing is giving me numbers that are just a little too low for me to think it would work right.
Actually, the last example in the textbook actually deals with the same type of problem.
Oh.
So in the textbook example, it's opposite. P equals 0.48, what is the probability of that the results of the survey will suggest that the candidate will win the election. So it's the exact opposite.
All right.
Right. So we need to find the following probability.
Well, let's see. All right.
Greater.
So, oh, okay. So what we
Right.
would use is
P.
we would do 0.5 minus 0.52. If that's what the according to the example, that's what we would do.
Yeah, that would give us a negative. That would give us a negative z-score, which makes sense because
Yeah. Divided by. Oh. Do you remember the original number? It was like a couple more ones of the standard deviation. Oh, I could just enter the whole thing real quick. It's not that hard.
standard deviation. What did you get for the standard deviation?
Oh, it was I got 0.01116 or something, or 1118. I don't remember. I did my syntax wrong. I missed something. How?
Standard deviation. I'm just trying to figure out what x would be in for this problem.
Oh, I think it'd just be 0.5. Or, yeah, 0.5 minus. The square root of. Minus 1 minus. All right, I'm getting. In the end, I got the z-score of negative 1, 7. I mean, negative 1.79. All right.
All right, so I think I got the same thing that you did for the standard deviation. Finally. 0.000125.
Hi, I'm finally here.
Tara,
Hi.
How far into the quiz are you? Fine. My dad's computer wouldn't let me. I had to upload plugins from 3 different. Firefox finally worked.
yeah. So we're working on the quiz at the moment.
Okay. Let me get everything logged in again.
So you're having to use your dad's computer?
Well, I'm in Washington State now, so yeah.
Oh, right. Good old Washington.
Yep. I'm in Kuala. Didn't occur to me to set everything up on Google Hangouts before. I'm afraid that was my mistake.
That's all good.
Can somebody go back to question 3 and just get me up to speed with where we're at?
Yeah.
Each slice represents the area of each slice represents the proportion of the that makes sense.
So we all felt it was C.
Yes, each slice represents a category of each, and the area of each slice represents the proportion. That makes sense. Our charts and Pareto charts are basically the same. Pareto charts ordered largest to smallest, left to right. Yes. So 5.
So this was just a definition. And it's kind of the same rule as x versus x bar.
Okay.
P
We had normally distributed if n times times p is greater than or equal to 10 and n times 1 minus b is greater than or equal to 10. I have that rule written down. Okay, so p is the true proportion of the sample, or the sample. Okay, so p is the sample proportion, I think.
Okay. We thought it was true proportion,
The true proportion. Okay.
but we may have been wrong.
I thought that was the p hat. a minute. I have a couple of things I wrote. I watched the video twice. I didn't write it down. All right.
So for the in the z-score equation, it's p hat minus p. That makes me think that p hat is the sample proportion as opposed to the population.
Okay, so for 6, what is n?
Oh, n is the same thing it's always been.
Sample size. Okay, that's what I thought. All right, and then if p is 1/4, what is the smallest n that satisfied the requirement? Is that what you were talking about, number 7?
No, it is the equations that you said you had written down, n times p greater than or equal to 10, and then n times 1 minus p is greater than or equal to 10.
Okay. So for question 7, if p is a 1/4,
the way we thought about it was what number times 0.25 would give us 10. Or what number divided by 4 would give us 10.
So 10 divided by 0.25 gives you 41.666 repeating. Round to the 10th place. So 41.67, is that what you had?
We actually just had 40. Because we were like, well, you divide 40 by 4 and you get 10.
Oh, I thought you said 10 divided by 0.25.
No, I meant what number divided by 4 would give you 10. And then for the other.
So what is? I don't understand. So like it's 3/4 of 10, which is. Okay.
It's just if the sample size times p, which is 0.25, is equal to or more than 10, then then it satisfies the requirement. So pretty much you just need to find you need to find n. So n times n times 0.25 needs to equal at least 10.
So n equals 10 divided by 0.25.
No, you need to find n. N equals anything. N can be anything.
Yeah, but so they're asking for the smallest n that satisfies the requirement, and if you n times 0.25 is greater than or equal to 10, if you just work that as a regular problem, 10 divided by 0.25 would make the smallest n, right?
Yeah.
The simple algebra.
Yeah, but then at the same time, it has to solve the other side too, because there's 2 requirements.
It has.
Well, just simple algebra, you can look at it this way. What times 0.25 equals 10?
That would be 40.
Yeah,
Okay.
that's what we were thinking. We haven't tested our theory yet.
Okay, so are you guys on 8, or are you a whole lot farther than that?
We're
We're
a
on.
bit further.
Yeah. What does it mean?
So n equals 24. And p equals
He came through. She's probably in her room. So Laura, do you know the number 8?
I'm not sure which formula I'm supposed to use.
So this one is just a it's more of a rule, I think, than an equation. It's basically the mean of p hat equals p.
Oh.
Yeah.
Well, it didn't like p. Oh, no, so I don't put p in. I put in p is 0.4. Got it. What is the standard deviation of p? That one I got. E times 1 minus p all over. So 0.4 times minus 0.4 all over 24. So for 9, I've got 0.01.
Yeah, that's what we got.
Okay. Brittany's batting average is 0.30. Okay, so if p hat is p, then 10 is 0.3. Did I get that right?
Mean of p.
Okay. This one's in the wording. Last one was what was the mean of p hat, and then this one was what is p hat.
Oh, what is p? So that's p hat is x over n.
Yeah, so we got confused about that, and what he talked about a few times is x is the
something of a significance. So the thing of significance is hits. So it would be 30. X would be 35.
So 35 over 100.
Mm-hmm.
And then round to 2 decimal places. Which is just 0.35 anyway. So then the standard deviation of P. Point 3 times 1 minus 0.3 over 100. Did I square root that last one? I don't think I did 9 right, because I don't think I did the square root of that. For 9, did you guys get 0.01?
Yeah. For P, wait, was it P? Well, wasn't that? Hold up.
That was standard deviation of P hat. I don't think I did that as a square root.
Yeah. For number 9, I got 0.1.
You got 0.1?
Yes.
Okay. I did do it wrong. All right. 11. So 11 is 0.17. 171.
That's 0.1.
71.
You said for number 11?
Yeah.
Make sure I didn't do it. I got a different answer. I'm going to look and see how I did it real quick.
You round it.
So for number 11, I had 0.3 times 1 minus 0.3, or
Yes.
the square root of 0.3 times 1 minus 0.3 over 100.
Oh, wait. I've got it over 10. That would be why it's 0.054.
I got,
More like it.
you got 0.54?
0.054.
Okay. I got 0.0458, which rounded up would be
Zero.
0.046.
Yeah.
0.05394. So 0.3 times 1 minus 0. Wait, there's an extra 0. All right. Heaven help me. So it should actually be 0.046 for 11.
Mhm.
Okay.
That actually helps you out for 12. So if you take that unrounded number, you can just put that in the bottom part of the equation for number 12.
What's the? I've actually been looking for that. What is the z-score equation?
It is p hat minus p,
I'm sorry. What?
p hat minus p over the standard deviation, which is what you just figured out.
Over the square root of the p times 1 minus p over n.
Yeah.
All right.
So
that's the 0.046 is the bottom.
yeah, we debated whether to use the 0.046 or the unrounded one, and we decided to go with the unrounded number.
Probably. So 0.35 is p hat minus 0.3 is p divided by what we just got 0.04. I gotta unround it. 0.04583.
Is that what you got?
When I unround it, it's 0.0583.
That's a little low for what? 0.
What did you get for number 12 with the unrounded number?
With the unrounded number, I get 0.09583. Haven't rounded it yet. So rounded 0.096. Is that what not what you guys got?
No,
Huh?
we had 1.091.
All right. What am I? So what was your answer for 12 then?
That was it.
Sorry, 11.
11 was unrounded is 0.045826.
I didn't go one more decimal place. I had 0.04583 because it had rounded it one more time for me.
Mm-hmm.
Let me. .35 is p hat minus 0.3 is p divided by, I'll just put the numbers in. I was doing the 0.0 45,826. I still get 0.096.
Hmm.
Wait a minute, that's not, hold on. Never mind, 1.091. All right.
Yeah,
Yep.
that's
I had
that's
a,
what we put down.
yeah, no, I had a parentheses in the wrong spot. There we go. 1.091.
Okay.
So what is the probability that Brittany gets at least 35 hits? Do we use the same, the normal, there we go, normal probability applet. So our z-score is 1.091. And we're asking for, it's just one-tailed, it's greater than, right?
We couldn't decide. So I did equal to and greater than, and I don't know what Eric did, but Trent did the
One tail.
yeah, one tail.
Okay.
Mom, can I take a bath?
Yes, John.
Okay.
Okay, so if it's one-tailed, it gives me a probability of 0.1376. Does that sound right, Trent?
That's what I put down. No, rounded to 3.
Yeah, so 0.138. Too many places to look. Yeah, so 0.138. All right. So are you on 14? Like, how were you done when I got in here? Is that what you're just waiting on me?
Second to last. We had done 14 together, and then I was working on 15 when you came in.
Okay.
I think Edward and Ed at Cardi have 15 though.
All right. So standard deviation p hat. P equals.
Whew.
Bless you.
Thank you.
Excuse me.
Bless you.
All right. So 52 minus, no, times 1 minus 0.52 gives me that. Divided by 2,000. Point 0.01569. So I have to round it to 3 decimal places. 0.016. So is 14 0.016?
Oh, let me. We got 0.011. Oh, actually, I think there's a 6 eventually. Hold up. Yeah, if anything, I may have gotten 0.1116.
Okay, I've got 0.01569968. So I rounded it to, all right, let's see if I did it wrong again. So, how do I keep getting an extra 0? All right. 0.52 times 1 minus 0.52. And then we divide that by 2,000 for the love of Pete. I love being rushed. 0.01117. So rounding it to 3, it is 0.011.
I must have set it up wrong because I got 0.0001248. So I just put down 0.000. It sounds like I had it set up the same way you did, though. I've got 0.52 times 1 minus 0.52 divided by 2,000.
And then the square root of.
Oh, right. Okay.
That's what I did the first time, as I didn't square root anything. All right, so z equals p hat minus p over what we just did, 0.011. And now I have to remember how to find p hat, or did they tell us?
P hat.
P hat is x divided by n.
Oh yeah, this one's a bit harder, but the only other number they give you of significance is 50, which is so the only thing it could be is 50.
Less than 50% of the votes.
So what I would do is what I was gonna do is use exactly 50, but then whenever you get into the probability applet, only choose the left side, so it's not equal to or less than. It's just less than.
Less than. Okay.
That's what I was gonna go at the end of that.
So p hat is 50 divided by 2,000, and that gives me 0.025. So 0.025 minus, what was p again? 0.52 divided by 0.01. Wait a minute, I probably want to minimize that. 0.01117,139. All right. Interesting. So I've got negative 44.309616. Is that anything like what you have for your z-score?
Negative? I got a negative 1.79.
Okay, so I've got, so p hat minus p is 0.025 minus 0.52, and then I have it divided by the unrounded 0.01117,139.
And what did you get?
Negative 44.309616.
And what did you put in as p hat?
0.025.
Where did you get that?
P hat is x divided by n, so that's 50 divided by 2,000.
Okay.
Am I doing so? What am I? What am I missing?
But for the most part, you're usually just typing in the numbers wrong.
I'm checking. So, p hat is 0.025. Yes.
P hat, it shouldn't just be 0.5.
50 divided by 2,000.
I just use 0.5. Because if you don't use 0.5, your number will be huge, or like hugely, well, really, really small.
But the formula says p hat should be 50 divided by 2,000, right? Or are you just saying because we're asking for less than 50%, just call it 0.5?
Let's see.
Yeah, I might have had that wrong. I might have had a wrong assumption as well. I did not. Because I just use 50 as p hat.
So getting less than 50% of the votes. Okay. So I will change that. I did x divided by n to give me p hat.
As we've been a little confused about what exactly is x.
I think X. I think last time we had to find X, and this time X is provided for us.
Okay. So 0.5 minus 0.52. Because I had I thought p hat would be that 50%, you know, or the 50 divided by 2,000. So that was my mistake. All right, so 0.5 minus 0.52. So I now have negative 1.790. And we're doing less than, let me get the right stuff. So just the left tail is highlighted. Negative 1.790. And that gives me a probability of 0.0367.
Yeah, I got the same.
But the z-score is, go back, negative 1.790.
That is a legitimate concern, though. Because if we didn't use the right p hat, I mean, the z-score using 50.5 minus 0.52, that yields a more realistic z-score, but
Well,
I don't know about that p hat equation.
Let's see. Because in what was it? In the last question set, they didn't give us p hat. We had to find it ourselves. This time, I believe it's given to us. That's why I didn't bother doing it, because when you do use the equation to find the p hat, it makes it way too small.
Yeah. Yeah, and the z-score makes sense when you use just 0.5 minus 0.25 or 52. Well, I guess there's one way to find out.
Okay, so 15 is negative 1.790 and 16 is 0.037.
That's what I have, and I'm about to submit.
All right.
We shall see.
%.
And I got the question 13 wrong, so it was only the right side, the one-tailed.
Okay.
All right.
Which made sense because of the way they were asking the question, I think.
Yeah, it made sense to me, except whenever I thought about it a different way, it made sense for it to be much larger. But all the different ways to think about it, it would make sense and not make sense. So I said, well, just to be safe, I'll do this and he'll do that.
Yeah.
Okay, well, cool, y'all.
So we're going to have to just pay attention. If they hand us p-hat versus asking us to find it, it's going to make a big difference.
Yeah.
I apologize for my lateness. Thank you for helping me speed through everything and not jacking the whole thing up. I'm sorry you had to wait on me.
No problem. Sorry if you felt rushed with our silence. I hate that too.
Are we meeting tomorrow or are we meeting Thursday?
Question, do we meet just for lesson 17 or do we have to meet again for the group assignment? If we have to meet
try
twice,
and all get it done at one time, or do we need to meet twice?
I say we try to do it. If we have to meet twice, I say we meet twice. Because it usually takes us about an hour to an hour and a half to get through the homework quiz or the group quiz.
Yeah, I think that'll be fine. Right. I think we should just meet tomorrow.
See how it goes.
Okay.
If we need to meet again, we'll meet again.
Okay, so tomorrow, what time, Mountain Time?
I don't see any reason to change. 5 o'clock 3 o'clock should be good.
Okay, so that's tomorrow. All right.
Could we meet a little earlier?
Yeah, that's fine. Yeah, that's fine.
How much earlier?
I was thinking about going out on the lake tomorrow evening, but I probably will need all the time I can get tomorrow afternoon for studying before our meeting, so we should probably just plan for the same time.
Okay.
All right. Well, yeah, we'll see. All right.
2
If we need
o'clock
to change
tomorrow.
it, we can change it. All right. Bye then.
Thanks, everybody.
Bye.
See ya.
All right.